Okay, this is Dr. Brown, and what I'm going to do is work Quiz 2 version 1 and also tell you the answers for Quiz 2 version 2. What I would like for everyone to do is look at your quiz and look at the ones you may have not gotten correctly and make sure you understand how to work the problem. Okay, the first problem is to take a derivative using the power rule, and this is pretty obvious that the first derivative is going to be minus 16 x to the minus 3 plus 3 times 13, which is 39 x squared plus 16, and that is answer C. If you looked at the one on version 2, its answer would have been D. Problem 2, we are asked to find the derivative and then find the value of the derivative at the specified point. And so we have to calculate g prime of x is equal to 3x squared plus 5, and then calculate g prime at 1 is going to be 3 times 1 squared plus 5, and this will obviously be 8. And that is answer C. Version 2 answer would have been D. Number 3, you also want to calculate the derivative and calculate the value of the derivative at the indicated point. And what you obviously want to do here is write that f of x is equal to 8x to the minus 1, so you can use a power rule. And f prime of x would be minus 8 to the power minus 1, which is going to be minus 2, which equals minus 8 over x squared. So f prime at minus 1 is minus 8 over minus 1 quantity squared equal minus 8, and that is answer D. And version 2, the answer would have been B. Problem 4, we have to use the quotient rule, and dy dx equals y prime. It's going to be the denominator, or the bottom, which is 4x minus 8, times the derivative of the top, or the numerator, which is 1, minus the numerator, which is x, times the derivative of the denominator, which is 4, all divided by the denominator squared. And you can see that this is 4x minus 8 minus 4x divided by 4x minus 8 quantity squared. And simplifying, we get minus 8 divided by 4x minus 8 quantity squared, which is answer D. In version 1, it would have been C. Problem 5, we want to take the derivative of f of x. Notice this is a product, and we want to use the product rule. So f prime of x would be equal to the first, which is x plus 5 over x, times the derivative of the second, which is simply 2x, minus the second, which is x squared minus 6, times the derivative of the first. Now, you would write the first as x plus 5x to the minus 1, and of course its derivative would be 1 minus 5x to the minus 2. Which is 1 minus 5 over x squared. So the derivative of the first is 1 minus 5 over x squared. And looking at the answers, the answer would be B. And version 2 answer would be C. Now, problem 6, we want to find the derivative of 7 over x plus 2 secant of x. We would rewrite 7 over x as 7x to the minus 1. And then 2 secant of x. The derivative of y then is minus 7x to the minus 2. The derivative of secant of x is secant of x tangent of x. So this is plus 2 secant of x tangent of x. And this is answer D. Version 2 would have been answer B. Problem 7, we're going to use a power rule and the chain rule. Y prime is going to be the power times our u, which is 3x squared plus 5x plus 1 to the power minus 1, which would be 1/2, times the derivative of u with respect to x, which is 6x plus 5, and that is answer D. And in version 2, it would have been B. Problem 8 is to find the derivative of the inverse sine of 4x cubed. Notice this is our u. We're going to have to use a chain rule here. You should know that d dx of inverse sine of x is 1 over the square root of 1 minus x squared. So this particular problem, dy dx equal y prime, is going to be 3 over the square root of 1 minus the u squared, which is 4x cubed squared, times d dx of 4x cubed, which is 12x squared. That's the chain rule. So the answer turns out to be 36x squared divided by the square root of 1 minus, that's 4 squared, which is 16, and x cubed squared, which is x to the 6. And so our answer is A, and in version 2, it would have been B. Now, problem 9, some of you tried to use a quotient rule, and some of you even got the answer using the quotient rule, but you did it the hard way. Remember what we talked about rewriting these kinds of problems if you only have one term in the denominator. So we would rewrite y as 2x to the minus 9 minus 2x to the minus 7 plus x to the minus 4. To further elaborate on that, this is 2 over x to the ninth minus 2x squared over x to the ninth plus x to the fifth over x to the ninth. And after you do this, you get the rewritten term as we have it here. That sets it up so that the derivative is very easy to do. You get minus 18 x to the minus 10 plus 14 x to the minus 8 minus 4 x to the minus 5, and it looks like to get the answer in one of the choices we have to bring the powers downstairs. We get minus 18 over x to the 10th plus 14 over x to the 8th minus 4 over x to the 5th, and that is answer A. And in version 2 it would have been B. I think maybe some of the numbers were different on the versions, but the way that you work them happen to be exactly the same. Problem 10 is a word problem. You have a zoom lens and a camera that moves in and out. The size of the rectangular image changes as this happens. At the moment, the current image is a length of 5 centimeters and a width of 4 centimeters. Find the rate at which the area of the image, and of course the area that the image is going to be the length times the width, is changing. If the length of the image is changing at 0.6 centimeters per second and the width of the image is changing at 0.2 centimeters per second. So obviously the area is going to be the length times the width, and we want to find dA dt. So that's what we're looking for. And we're given that dL dt is 0.6 and dW dt is 0.2. So dA dt is ddt of L times W. The first thing you should notice, and we've done problems like this before, is that this is a product, so you need to use the product rule. So dA dt is the first times the derivative of the second, which is dW dt, plus the second times the derivative of the first, which is dL dt. And now we just simply need to plug in that L is 5, dW dt is 0.2, W is 4, and dL dt is 0.6, and this happens to be 1.0 plus 2.4 equals 3.4, and that is answer B. For version 2, the answer was D. It's worked exactly the same way. Problem 11, we are given 4 graphs, or 4 sets of graphs, in which one is a function and the other is supposed to be its derivative, and we're told that only one of the choices is correct. You want to circle and mark your answer A, B, C, or D. Well, one of the things we're told to look at is, to get yourself some clues, is to look at the function and see where its derivative is 0. So just going to B we notice that the value of f is, its tangent line is going to be have a slope of 0 at this point, and also at this point. And notice that f prime is going through 0 at those points. Also here it's going through 0, and here it's going through 0. So that could be a candidate. However, if you look at f between here and here, f prime has a positive slope, but f prime is less than 0 over that interval, so that could not be it. If you look a little more, you see that A is the right answer, because at this point the derivative is 0. At this point on f, the derivative is 0, and the f prime is 0. At this point, f prime, the slope of the tangent line is 0, and f prime is 0 here, and so it is here. And the other clue is that f prime is more than 0 between here and here, and notice that the corresponding f prime does indicate that it's positive. So the answer is A. For version 2, it's answer D. Now number 12, we want to find the derivative of y equal ln of 9x. The important thing to remember, of course, is a chain rule, and also that d dx of plain old ln of x is just 1 over x. So dy dx is going to be 1 over 9x. Notice the u is 9x times du dx, which is going to be just simply 9. So that equals 1 over x. And that is answer B. And version 2 would be answer C. Number 13, we're given that the position of a particle given by S equal the square root of 3 plus 6t, which is 3 plus 6t to the 1/2 power. And we want to find the particle's velocity at t equal 1. So we need to find S prime is equal to V. The derivative then is 1/2 times 3 plus 6t to the minus 1/2 power times the derivative of 3 plus 6t, which is 6. That's the chain rule. So the derivative is 3 over the square root of 3 plus 6t. And we want to find that at t equal to 1/2, which is going to be 3 over the square root of 3 plus 6 is equal to 3 divided by the square root of 9, which is 3 over 3 equal 1. So the answer is C. And in version 2, the answer is A. Number 14, you were to find the derivative of this function. It's obviously a chain rule problem. You would write down that y prime is a power times 2x to the 4th plus 6x to the power minus 1 times the derivative of u, which would be 8x cubed plus 6. So that's version 1. Version 2, you were given 2x to the 5th plus 10x to the 7th power. So y prime for that version would be 7 times 2x to the 5th plus 10x to the 6th power times the derivative of the u, which is 10x to the 4th plus 10. Problem 15, you're given the position of a body moving, and you want to answer the question, when is a body moving backwards? Well, the body is moving backwards when s prime equal the velocity is less than zero. Well, looking at the derivative or the slope of the tangent line, we will see that that happens when the slope of the position is negative, and that's where I have indicated in heavy ink here. And so that answer is obviously between 2 and 3, between 4 and 5, and between 7 and 9. Now that then is answer D. For version 2, the question was, when is the body not moving? Well, that would be when the derivative of s, which is the velocity, is equal to 0. So looking at the slope of the tangent line, that would be between 1 and 2. So that would be t between 2 and 1. And that would have been your answer A. Some of you put incorrectly that it was at t equals 0, t equal 3, t equal 5, and t equal 8. That would have been incorrect, because that is just where the body is at the home position at s equals 0. The velocity is not 0 at that time. Problem 16, you're supposed to use implicit differentiation to find dy dx. So we do d dx of x to the 6 minus d dx of 2x to the 4th minus d dx of y cubed equal d dx of 10, and so we get 6x to the 5th minus 8x cubed. And here we have to take first the derivative with respect to y and multiply using the chain rule dy dx. So we get minus 3y squared times dy dx. And d dx of 10, of course, is 0. And solving for 3y squared dy dx, bringing this over on this side, we get 6x to the 5th minus 8x cubed. And so dy dx is 6x to the 5th minus 8x cubed divided by 3y squared. And that is answer B. And on version 2, it would have been answer C. Now, problem 17, for the given function, you were to find the points on the graph at which the tangent line has a slope of 1. That is, y prime is equal to 1. Now, y prime is simply x squared minus x plus 1, and we want to find the value of x that makes that equal to 1. So we simply get x squared minus x equals 0, or x times x minus 1 equals 0. Solving for x, we get x equals 0 is one solution, x equals 1 is the other solution. Plugging these values in and getting the y value, get 0 and 0. Plugging 1 in, we get a y value of 5/6. And so the answer is D. For version 2, it would have been answer A, and your function was y equal 1/3 x cubed minus 3/2 x squared plus x, and of course y prime would have been x squared minus 3x plus 1. That would have equaled 1, and then you get x times x minus 3 equals 0, and x equals 0, and x equals 3. And the points would have been 0 and 0, and 3 and minus 3/2. And as I said, that would have been, I believe, answer A. And finally, the last problem. Find the derivative. Here you just rewrite the problem with a negative exponent and write that as x to the minus 2.4 minus pi x to the minus 1/2. So dy dx is minus 2.4 x to the minus 3.4 plus pi over 2 x to the minus 3/2, and that is answer B. And if you look at version 2, it would have been answer D. And that is quiz 2. A lot of you had some great improvement on this test, and I was very proud of you. Those who had a little bit of a downturn, come see me, ask me any questions, and I wish you well on the next quiz.